All right, guys, in this chapter, we're going to start talking about something called quadratic functions. Now, what are quadratic functions? Quadratic functions are non-linear equations. Okay, what that means is when we start graphing quadratic functions, they are not going to be straight lines. They're going to have a very unique shape to it. They're non-linear and can be written in the form. Here is what a quadratic function looks like. It's going to follow the format of ax squared plus bx plus c. Okay, so this is like the y is equal to mx plus b of this chapter. Okay, things that look like ax squared plus bx plus c qualify as quadratic functions. Okay, if you see a symbol that is x squared, it is a quadratic function. A, b, and c are just numbers though. Okay, what are the rules? A cannot equal 0, but those other numbers can be whatever you want. Okay, this is called the standard form of a quadratic function. There's multiple ways to write a quadratic function, but this is the most common way. Ax squared plus bx plus c. Okay, so what is a quadratic function? Most of you guys have heard of this shape before, but the shape of the graph of a quadratic function is called a parabola. Okay, so what do you need to know about parabolas? Parabolas are symmetric. What does symmetric means? It means you can cut them directly in half and have it look exactly the same on both sides. Okay, they're symmetric about a central line called the axis of symmetry. I know I'm throwing a lot of vocab words at you right now, but just bear with me. So what this means is you can cut your parabola in half among this imaginary line called the axis of symmetry. Okay, the axis of symmetry intersects a parabola at a very special point. And what is that special point called? It's called the vertex. Okay, what is the vertex? It's either the top or the bottom of a parabola. Okay, so a lot of words going on so far, but let's just start with like the simplest type of quadratic function I could give you, the simplest type of parabola. Okay, we'll call this the parent function. Okay, all of our parabolas that we'll make in this course will stem off of this very, very simple type of equation. Okay, so the simplest type of parabola I could give you is just the equation x squared. Okay. It still follows the format of ax squared plus bx plus c, but there's the simplest numbers possible for b and c and a. Okay, so what is this equation written in standard form? It's just the same thing as 1x squared, which is just x squared, plus 0x, b is equal to 0, and then c is also equal to 0, plus 0. Okay, so let's just look at the parent function called x squared. What type of graph is it? What is the shape going to be? Okay, because you see an x and you see a squared symbol, this is going to be a parabola. Okay, so let's start with this. Whenever I ask you to make a graph of something and you have no idea what it looks like, here's what I want you to do. I want you to make an input-output table. We've done this before. Plug in some values for x and then get some values back for y and plot a bunch of points. Okay, so I asked myself, I can plug in whatever number I want in for x, so I might as well pick the easiest numbers possible. Okay, so I asked myself this question. What's the simplest number I could plug in for x? Well, 0 would be pretty easy. If we plug in 0 into this equation up here, what do we get back for y? Remember, this is y is equal to x squared. If I plug in 0 in for x, what do I get back for y? 0 squared is equal to 0, y is equal to 0. Okay, so what do I know? I know I have the point 0, 0 on this graph. Okay, what's another easy point I could plug in? Well, how about 1? When I plug in 1 into this equation, what do I get back? 1 squared is the same thing as 1 times 1. 1 times 1 is equal to 1. When I plug in 1, I get back 1. I know I have the point 1, 1 on this graph. Okay, what's the third easiest point? How about 2? Okay, if I were to plug in 2 in for x, what do I get back for y? So 2 squared is the same thing as 2 times 2. 2 times 2 is 4. When I plug in 2, I get back 4. So I know I have 2 comma 4 on this graph. Okay, so it's always a good idea to get some positive numbers, but we should probably get some numbers to the left of 0 as well. So what's the easiest negative number I could plug in here? In this case, it would probably be -1. Okay, if I plug in -1, what do I get back? So if I have a -1 times a -1, a negative times a negative equals a positive. If I plug in -1, I should get back +1. I know -1 comma 1 is going to be one of these points on the graph. And then if I plug in -2, a negative times a negative is a positive. 2 times 2 is equal to 4. -2 comma 4 is one of these points on the graph. Okay, so we have seen this before. We've introduced it slightly. If you guys remember this one, a parabola is kind of like a fancy U that goes up forever and ever. Okay, I'll call it a smiley because it's opening upward to the right, or going upward towards the y-axis. Okay, this is a parabola. It's the simplest type of parabola I could give you. Y is equal to x squared. So let's talk about some of the properties of this parent function. Okay, so the axis of symmetry is the imaginary line that cuts the parabola in half. Okay, there's always a formula to get the axis of symmetry. Okay, if I ask you to solve for the axis of symmetry, here's all you need to do. It's always going to be a vertical line. It's always going to follow the format of x is equal to -b over 2 times a. Okay, it looks super ugly, but if you know all the numbers to plug into this equation, it's going to be pretty simple. So I look at my original equation in standard form, x squared plus 0x plus 0. And I try to figure out my axis of symmetry. So it's still going to be x equals a number. And what is -b? Okay, well b is the second number here. In this case, it's 0. My numerator is going to be equal to 0. And my denominator is going to be equal to 2 times a. Well, a is the number in front of my x squared term. That's not a 0. Remember, that is a 1. So 2 times 1 is equal to 2. So my axis of symmetry is x equal to 0 over 2. And if I simplify that, it's just x is equal to 0. Okay, so this looks kind of funny, but what this is it's an equation of a line. And whenever you have x equals a number, here's what you need to know. It is a vertical line. It's a vertical line at this number. So the line x equals 0 is right smack dab in the middle right here. Directly on top of the y-axis. Okay, and what we notice here is that this orange line is cutting this parabola directly in half. The line x equals 0 is cutting the parabola straight down the middle. So it looks exactly the same on both sides. That's what it means to be the axis of symmetry. I'm looking for the line that cuts it in half. Okay, now the vertex is always a point on the parabola. Okay, it's going to be one of two things every single time. It's either going to be the bottom of a smiley. In this case, what we're looking at right here is a smiley. It's opening up and going up forever and ever. Or it could also be the top of a frowny. So what I'm looking for is the bottom point here. In this case, it is this point right here, the lowest point on my smiley. And I'm asking, okay, if it's the vertex, what is the coordinates for that point? It looks like the points are 0, 0. Okay, so I just talked about how there's going to be two different types of parabolas you're going to see. There's going to be smileys, and then there's also frownies. Okay, how do you know if you're going to be dealing with a frowny or a smiley? It's pretty simple. If it opens up, if it's a smiley, in this case it's a smiley, it opens up if a is bigger than 0. Okay, if a is a positive number, it's going to be a parabola that opens upward. In this case, a is equal to 1. 1 is a positive number. It's opening towards the sky. It's going to be a frowny if it's the exact opposite. If a is less than 0. Okay, in this case, it would be a parabola that's opening downward. And then to solve for the y-intercept, all you're really looking for is what is the place where this thing crosses the y-axis. Okay. In order to find that point, all it's going to be is it's going to be the point 0, comma, and whatever c is equal to. Okay. In this particular example, we're dealing with the parent function. C is equal to 0, so the y-intercept is the point 0, comma 0. And it crosses the y-axis right there. All right, some more vocab for you guys. The lowest point on the graph of a parabola is called the minimum. Now, what's important to know is that there's only a minimum when a is bigger than 0. Okay, only smiley faces have minimums. Okay, but on the contrary, the highest point of the graph of a parabola is called the maximum. But this only happens when you're dealing with quadratics that have an a value that is less than 0. Okay, if it's a frowny, it's going to have a max, but if it's a smiley, it's going to have a minimum. Okay, the max or the min, what we just talked about. I'm sorry, let me erase that. The max or the min is another word for the vertex. Okay, what the vertex is, once again, all it is, it's either the bottom of the smiley or the top of the frowny. Okay, to graph a quadratic, you got to go through certain steps or certain requirements, but we can use the axis or line of symmetry to help us. Okay, the first time we did this, we made an input-output table, and we had to, you guys probably agreed it was a little bit tedious to go through all those points. Okay, we don't want to have to do that every single time whenever we're graphing parabolas. We can use that axis of symmetry to help us. Okay, so what I'm requiring is whenever you make a parabola in this class, I need you to have 5 points. Okay, what are the 5 points I need you to have? One of those 5 points needs to be the vertex, and I need you to have 2 points on one side of the axis of symmetry. But once you have those 2 points, you can then reflect those points across the axis of symmetry.